Ever wondered how your devices communicate with each other? It's not magic, it's all about protocols. Protocols are the rule books of the digital world, ensuring data is transmitted efficiently and reliably between devices. Let's take a look at some key players. First off, we have the Transmission Control Protocol, or TCP. This connection-oriented protocol establishes reliable communication streams between devices. When you're browsing the web, TCP acts like a vigilant postman, ensuring web pages are delivered correctly with any missing or corrupted data retransmitted. Next up is the Internet Protocol, or IP. It's the navigator of the digital world, providing the addressing and routing framework necessary for transmitting data packets. When you send an email, IP ensures that your message finds its way across the internet to the right recipient. Finally, meet Hypertext Transfer Protocol, or HTTP. It's the go-between for web servers and clients, facilitating the retrieval and display of web content. So, next time when you're browsing the web, remember, it's the protocols that make it all possible. Now that we understand protocols, let's move on to network topologies, the layout of our devices and their connections. These topologies are like the blueprints for a network, outlining how each device is connected to the others. Let's take a look at some common examples. First up, we have the star topology. Picture a central hub or switch with devices connected like spokes on a wheel. This is a star topology, often used in Ethernet local area networks for its easy scalability and centralized management. Next, we have the mesh topology, where each device is directly connected to every other. Imagine a tightly knit fishing net that's a mesh network for you. It's commonly used in large-scale internet backbones for its high fault tolerance. Lastly, we have the bus topology. Picture a common communication line, like a bus route with stops or devices along the way. It's less common today due to scalability issues, but was traditionally used in Ethernet networks. Different topologies for different purposes, but all ensuring your data gets where it needs to go. Finally, let's dive into network architectures, the overall design of our network. Network architectures are the blueprints that shape the structure, organization, and interaction of components within a network. They dictate how information flows and how devices communicate, providing an essential framework for efficient and reliable data exchange. Two common types of architectures are client-server and peer-to-peer. In a client-server architecture, one or more computers, known as servers, provide services to other computers, referred to as clients. This centralized setup is often used in business environments, where servers host applications and data for multiple clients. On the other hand, a peer-to-peer architecture allows all network devices to function as both clients and servers. This decentralization allows direct sharing of resources and data among peers, often seen in file-sharing applications. In essence, network architectures are the guiding principles that build the highways of information travel. And there you have it. From protocols to architectures, that's the fascinating world of networking in a nutshell.